The James Webb Space Telescope sent a stunning warning to Earth, coming from the exoplanet Proxima B. Each new photo that is posted raises more questions and worries the authorities. These images make us think about the mysteries of the universe and the growing questions about the planet near the Earth. Is there a nearby alien world with evil intentions? Will Proxima B pose a threat to our existence? The search for extraterrestrial life has fascinated humans for centuries. With recent advances like the James Webb Space Telescope, we can examine this question more closely than ever before. But the world doesn't take it easy. We continue to use our best instruments, such as the James Webb Telescope, to image views of distant planets and galaxies in hopes of finding signs of life beyond Earth. In fact, each new character and each piece of information brings to mind a little familiarity. While the findings are revolutionary, they also highlight the breadth and complexity of the universe, leaving more questions than answers. Capturing a distant planet like Proxima B could redefine our place in the universe. For scientists and astrophysicists, it is exciting, but for the general public, it seems like just another story about space travel, distant, abstract, and sometimes overwhelming. These revelations lead many to wonder what it means to live on Earth. Could Proxima B hold life or aliens that will one day threaten us? As powerful as the James Webb Space Telescope is, it can only show so much. We have discovered some amazing facts, such as the new images of Proxima B, which reveal that the universe is bigger than we thought. But what happens next? The scope of these findings is equally global. Proxima B, identified in 2013 by collision with a star, is a major scientific achievement. Discovering this exoplanet is like finding a new neighbor. Proxima B is slightly larger than Earth and orbits the star every 11 days, making it a fascinating subject to explore further. The thought of another world so close to ours is universally exciting, but it's hard for most people to talk about a place 25 light-years away. Even the fastest spacecraft ever built by man will take tens of thousands of years to reach. Imagine you are standing on Proxima B. The star, Proxima Centauri, emits a faint red glow in the sky, much cooler and dimmer than our sun. Proxima B orbits approximately once a year in just over a week. One side of the world is always facing the star, resulting in eternal daylight, while the other side is thrown into eternal night. Although it sounds like science fiction, the reality is more complicated. On the bright side, all the water may evaporate from the heat, but on the dark side it turns into solid ice. Also, Proxima Centauri is not a permanent companion like our sun. It emits flares and intense radiation, making Proxima B's surface a dangerous place for life as we know it. This is not an area where people want to live. Interest in extraterrestrial life increased in the late 2020s when scientists discovered unusual signals from the Alpha Centauri system, home to Proxima Centauri. The signal frequency of 982.551 MHz attracted worldwide attention and may indicate advanced technology, although it is still too early to draw conclusions. Recently, the James Webb Telescope added to the excitement by suggesting that Proxima B contains a water vapor. Water is an essential element for life, and this discovery could be a game-changer to better understand the water content of Proxima B. Scientists are using advanced techniques such as fluorescence, which can detect gases around the planet by analyzing the light spectrum. This technique can detect gases necessary for life such as oxygen, methane, and carbon dioxide. Wind modeling is a critical approach that uses computer simulations of Proxima B's atmosphere to make educated guesses about its properties. These models work in the same way that scientists reconstruct dinosaurs from fossils. The more we learn about Proxima B's atmosphere, the more we will be reminded of the diversity of life on Earth. Extremophiles, tiny organisms that survive in hot springs, salty lakes, or the freezing conditions of Antarctica, show that life can adapt and thrive in conditions thought impossible. Possible. Is life on Proxima B just as compatible? The search for life on Proxima B is a huge challenge. The world is bombarded with intense radiation, and the atmosphere provides little protection. In addition, the distances are so great that a new propulsion system is needed for space travel to Proxima B. Ideas like solar, ion propulsion, and even conceptual ideas like warp drives are being explored, but these technologies are still in their infancy. It requires extensive research before it can be used on real missions. While the prospects for future space travel are exciting, we must be realistic. Detecting life on Proxima B will involve technical and scientific hurdles. As technology advances and our understanding of the universe deepens, we can hope to unlock the potential of distant planets like Proxima B. This goal is not just about curiosity, but about expanding the boundaries of human achievement. Could we one day set foot on Proxima B or talk about life there? The concept of finding aliens is no longer the stuff of science fiction, but it seems like a real possibility. This move has drawn attention from organizations like Breakthrough Initiatives, which are committed to turning what used to be a long, impossible journey into a mission that can be accomplished in years. 10. The goal of reaching another star system within a human lifetime sparked innovation and hope in the scientific community. However, these lofty ambitions are hampered by the realities of our current technological limitations. Despite the great progress in space exploration, getting to Proxima Centauri, even though it is 4.2 light-years away from us, is a huge challenge. Our current distribution systems are not fast enough or efficient enough to do that in a timely manner. Breakthrough Starshot, one of the most ambitious projects, plans to use powerful laser beams to propel small spacecraft up to 20% of the speed of the Moon. Although promising, the concept remains to be tested and faces significant challenges such as minimizing damage from space debris and ensuring accurate communication over long distances. Accelerating a spacecraft to near light speed is nearly impossible with today's resources, as is solving challenging puzzles in the dark. Even ambitious projects like Starshot, which aims to launch a spacecraft to Alpha Centauri using lasers, run into many problems. Earth's atmosphere interferes with lasers and interferes with the performance of space probes and precision instruments. One proposed solution is adaptive optics, smaller lasers on satellites that constantly adjust for atmospheric problems to support lasers on the ground. However, laser electronics require a lot of energy, about as much energy as the entire United States for a short period of time. Imagine 100 million lasers over a large area just to propel a small plane at 20% of the speed of light. At this speed, it would still take 22 years to reach the Alpha Centauri system. Longer than many lifetimes, the challenges of getting to Alpha Centauri go beyond technical obstacles. Natural obstacles such as the sun's energy, space debris, and long distances can cause serious problems. Even communicating with a spacecraft headed for Proxima B is like sending a message through time, because signals take 4 years to travel from Earth. Despite these challenges, there is a growing interest in exploring other star systems, fueled by humanity's desire to see them. Addressing these issues could revolutionize space exploration, but the associated problems, including communication delays and environmental threats, require careful planning. Many researchers believe that the benefits outweigh the risks. Finding life on Proxima B or other distant planets would be a major achievement that would revolutionize our understanding of the universe. The discovery of extraterrestrial life not only changes how we feel about ourselves, but also provides insight into the origins and future of life on Earth. Discovering planets like Proxima B is just the beginning. Instruments like the James Webb Telescope allow us to study planets before they are too faint to observe. As we gather more information about Proxima B and other planets, we will expand our understanding of the universe and life beyond Earth. The James Webb Telescope has opened up new ways to search for extraterrestrial life, especially by discovering exoplanets like Proxima B. Although we are still just beginning to explore this world, so technology and curiosity drive us to push the boundaries of our knowledge. Whether Proxima B supports life or not, the ability to understand it has changed the way we see the world and ourselves. The search for life outside increases the motivation and enthusiasm to explore the world. Advances in technology, particularly astronomy, allow us to look further into the past and analyze the atmospheres of distant worlds for signs of life. Proxima B's location in the star's habitable zone, which has a liquid state, is interesting. Scientists believe that if the climate is favorable, it can support life forms that are very different from those on Earth. The study of Proxima B also provides insight into the conditions that could affect the life of our planet. By studying its geological and atmospheric properties, scientists can learn more about the formation and evolution of planets in different star systems. Astrobiology, the study of life on Earth, plays a vital role in this exploration, not only to find life but also to understand its ability to adapt to extreme conditions. This knowledge could improve our search for life in previously uninhabited regions, such as icy moons like the methane lakes of Europa or Titan. The excitement surrounding Proxima B is beyond life. It reflects a deep human need to see and understand our place in the world. As we ponder life on Proxima B, we are reminded of the many mysteries that lie ahead. Whether we find signs of life outside or not, the search for it brings us closer to understanding the great beauty and complexity of life.